What's up, guys? Let's take a look at today's Advent of Code, the first day of 2023. We get a story about this machine the elves are calibrating, and the machine spits out some pretty ugly data where we need to grab the leftmost digit and the rightmost digit, put them together for a two-digit number. Sometimes it's easy, like here, when it's the leftmost and rightmost character. Other times we have to dig into the line a little bit until we hit one, or the same thing from the right. Now, they give us some test data for part 1, so we'll try it on that, and then on the big data, which is, I believe, 1,000 lines. I've already got a file with this stuff prepared, so we got the big data and then the tests. There's another test for part 2. So let's say, okay, I'm going to do 3 steps. I'm going to get the digits, and then put them together, and then do the math. So I'm going to say digits, and I'm going to make a lambda function for each of these. It might be silly, but I like to separate them out, and I like to just think in that functional way. So L is the line, and we'll go C for C in line, C meaning character, if C dot is digit. And that's going to be a list because in the next step, we're going to index first and last. But let's test it out. Let me show you what's happening. So I'll go for line in test 1, print digits of the line. Okay, so that prints like, 2, 3, 1, 2, 3, whatever, because, oh, right here, this is the one we're looking at, 1, 2, 3, 8. Because it's 1, 2, 3, 8, and so on. So now we can say, all right, let's do the next step, which is to, they call it calibration, the 2-digit number. I'm going to go lambda d, that'll be our digits, and we're going to say d0 plus d -1, and this plus is not math, this is, concatenating strings, but then we're going to turn it into a number like that. And then the final part of part 1 is to just sum the calibration of the digits of the line for line in, let's try the test first, and then we'll go print part 1, because I would look silly if I forgot that part. And now if we do it, we get 142. Is that right? Yes, 142 is 12 plus 38 plus whatever. So now let's do it with the big data, which is, exactly 1,000 lines. So all I have to do is change this. I called it lines earlier when I read it out of the file, and I'll probably have that exact same thing every day on these. So now if we run it, we get 53974, and in fact, that was the right answer when I did this earlier. But when I did this earlier, I had my text normal sized and people said they couldn't read it, so now I made the text huge. Part 2 is a little more complicated because they have words in there that count, like TWO, that's a 2, and that's the leftmost digit of our big number. And at first, I thought that was going to be easy. We just do the string replace, NINE turns into the character 9, FOUR turns into the character 4. So let me show you what happens when you try that, and then we'll have to fix it to make it actually work. So I believe, if I remember right, yes, my clipboard includes this dictionary, so you don't have to watch me type it. And I'm going to make one more function. I'm just going to call it convert, and it takes a line, and let's say for word digit in worddict.items, because items is how you get both sides of a dictionary. We're going to go L dot replace word with digit, and then we return L. So this is like replace the word 1 with the character 1, replace the word 2 with the character 2, all the way down the line. And then part 2 is almost the same as part 1 with that one extra step. So we take the calibration of the digits of the converted line for the whole thing. And then we'll print part 2. And I'll do it on the test data first. So it should be not this. Okay, 211 is not it. 281 is what it should have been. And why is that? Because the first line works. We get a 2 and a 9 and we make 29. The next one, there's a problem, right? Because if we replace the TWO with a 2, then we lose the 8, because the 8 and the 2 overlap. When that happened to me, I thought, okay, let's just go backwards. Let's go 9, 8, 7 all the way down. But they have some that fail that way too. Like I think right here, if you replace the word 8 with the character 8, then you miss out on the 1, which is the real leftmost number in this line. So, okay, instead, we just have to look through the line. We actually have to look through the line and say, I'm going left to right. Am I hitting a digit? Am I hitting a word or the beginning of a word? And then I just keep going through the whole thing, because I don't know, I might hit one later that changes the rules or that changes the situation. So, okay, fine. For the convert, we have to do a little more work. And I'm sure there are more efficient approaches, but I'm just going to do pretty straightforward, look at everything. So I'm going to say, like, okay, for each character, we're going to enumerate through the line and say, if this character is a digit, okay, then that counts. That's something. And I'm going to put it in a thing. I'll just call it res for result. Okay, the classic. And if C, meaning this character, is the beginning of a word, then that might also count. So unfortunately, I can't just check a word. I have to check all the words. So I have to do the thing we all hate, which is to put a for loop inside a for loop. Okay. And this is the same thing we had earlier, except instead of replacing, we're just looking. Like, hey, is this the beginning of a word? I don't know. If line from I onward dot starts with, and starts with is a lovely method that does what you think it does. It looks, as far as it needs to see if that string starts with the other string. I know Rust has a starts with on their strings, and I'm sure other languages do too. So if it starts with that, not from the beginning of the line, but from wherever we are, then we got to put that in our result as well. And we're not putting the word, we're putting the digit, because the digit is going to play the role, like kind of replacing, but it's not messing with the letters that it was before. So we return res. Is that right? I don't know. Let's see. Hey, look at that. We got 281. Now, that's not guaranteed, because earlier I tried a different approach that worked with the test data, but not the big data. So let's try. Does that work? 52840. Let's see. Hey, it was 52840. So that's day 1, and it was harder than I thought. Yesterday I opened up a previous year's day 1 just to kind of remember how this works, and just crushed it in a few minutes. So I was kind of surprised that this really threw me off in part 2. Maybe I just got cocky. Maybe there's a easy way that I didn't think of. Maybe a regular expression wizard could write 2 lines and do it, no problem. Although I think it would be basically doing this anyway if you did it through regular expression. I'll check out YouTube and see what other people have done, and you guys should do the same if you're watching me. Do not take this as the right answer. Take it as just some guy figuring things out. And we'll see how it goes if I get all the way to day 25, or if I get crushed by some difficult ones halfway through. Thanks.